more or less we're going to talk about complex function analysis. So what happens is, in general, when you write down a function, you can actually separate it out in terms of the real and the complex function. Okay, and such functions can be analytic or may not be analytic, and for that we actually need to know the definition of, let's say, analytic function. So let me just write down the definition of analytic function first. So a complex valued function, okay, let's say w is equal to f of z. So there is something which is called the z space and the w space. I'm going to explain that, and that's why I've written it as w. It's not very complicated, just a concept that we're going to use is said to be analytic at point. So you can actually say a function is analytic at a point, or it is actually analytic for an entire range of points, okay, and so on. So we'll see examples when it will be more clear. At tau is equal to tau naught, let's say, if dw divided by dz, okay, we take the differential of that, and that's of course fz, f dash z, okay, and write it down as f dash z is equal to, and we can use the definition of limit here, limit delta z tends to 0, Kronecker delta, very small value, right? And you know how to write down the differential form of this. This is f of z plus delta z minus fz. So when you did limits in your class 12, okay, 11, 12, you might have come across this definition of, differentiation, okay, this is there. So you'll basically say that it's analytic at this point if this is there and this exists, okay. You basically are going to get a result out of it, so that means it exists, okay, and is unique at tau naught, let's say. So basically it's unique at that particular point, okay. Or maybe I can just write it down as z only. Why should I include the new variable? I can write down z is equal to z naught. I can just write down z z0. So at z naught, it should be having a unique answer, and that then only we can say this is more or less analytic. Okay. They are also, analytic function. Write it down here. They are also called as regular functions sometimes. Or holomorphic, okay, holomorphic function, okay. So they are called regular function or holomorphic function. You have to just remember that, okay. Now, if you want to actually define a function in the xy plane, okay, and you want to include the real part and the imaginary part, we can do it in this way. I think this is something which you might have come across when you did your, introduction to complex numbers. Okay, you can basically have the x-axis and the y-axis representing that function, right? Maybe there is a point which is 2 and 3, and it lies in the real plane and the imaginary plane. So what you can do is you can just simply write it down as z is equal to x plus yi, right? So this can be written as x plus I y. So if you just consider this particular point, you can write it down as 2 plus 3i. Okay, and this plane on which you are actually representing this imaginary number, which has got a real part and an imaginary part, we basically call it as the z plane. This is your z plane. Okay. In a similar way, it's not that you will just have one point of the z plane. You can have a number of points. And if you represent all those points, you basically just represent it in terms of the W plane. Okay, and that is what is W plane is all about. So maybe I will just give you this brief here. So let's say you've got a point U and V. and this is actually we are representing it in the W plane. So this function can be written as W is equal to f of z, okay, and this is nothing but u plus iv. And what is this u? U is a function of x and y. So that means we are talking about all the real, and the imaginary parts here. Because the real parts u here, and then v can also be a function of x and y. This is actually nothing but called as the W plane. Okay. So all z planes, we can say in general, we can say all z planes makes the W plane, maybe makes the W plane. Okay. So you can have a set of x and set of y, okay, a set of real and set of imaginary numbers, and you can actually represent it on another plane, which is actually the W plane. So this is more or less a combination of the x, y planes all taken together. So this is actually the beginning, and this is where we are talking about the complex analysis. And if I tell you to give a very basic definition of when we can say a function is analytic, you can just give this definition and that's it, okay. But we are going to see a theorem based on which we can say whether a function is analytic or not, okay. And this is basically called as the Cauchy-Riemann formula, okay. So I'm not going to go too deep into it, but we are going to straight away solve numerical problems. So Cauchy-Riemann, okay, I'll just write down it as CR for ease later on. Maybe I'll just write down CR, then we will understand this Cauchy-Riemann equation. Okay, and what we can do is we can actually use this to check if a function is analytic. Okay. So if you want to check whether a function is analytic or not, you can actually use the Cauchy-Riemann equation. And what is this Cauchy-Riemann equation? Cauchy-Riemann equation says that del u divided by del x is equal to del v divided by del y, and del u divided by del y is equal to minus of del v divided by del x. Okay, so if this is satisfied, we say that the function is more or less analytic, and this is what is Cauchy-Riemann equation is. Okay, we're going to see this. So for this, obviously we have to take an example, and then only we can understand it better. So let's just take up an example here and see how can we use the Cauchy-Riemann equation. Okay, and let's say I have an equation f z is equal to z square. The question is analytic or not, okay, whether this function is, okay, function is, there will be a straightforward question, is analytic or not. It's not mandatory that all function will be analytic, okay, it may be analytic, it may not be analytic. So let's just, proceed, write down this as z square. And z, z is something which you can actually write it down as x plus iy. We have just seen it. Okay, I'll just do it that way. So I'll just write it down as x plus iy whole square, and then we can expand it, right? So this is x square, a square plus b square. So b square means iy square. So I square is minus 1. So I hope all of these things are clear to you. I square is minus 1. I is root over of minus 1. Okay. So revise these things. Recall these things. So I square is minus 1, and then this is y square. So this will be x square minus y square plus 2ab. So 2ab, right? So ab means it is I x y.
Yes, sir.
Okay. 2I x y. Correct. Now,
Yes,
I can actually
analytic function.
Yeah.
It is an analytic function. I found that.
Right. That's an analytic. So what we can do is we can actually separate out the real part and the imaginary parts. Is this our first problem? So let's go a bit slow. So, I can simply say u, which is the real part, is x square minus y square. So you have to follow these steps. That's very important. Okay. And the v part, which is actually related with the I term. So whatever is I, just leave it aside and keep the remaining term. So it will be 2xy. So see, these are the steps. Okay, you have to remember this. Take the z function, write it down in terms of x plus iy, expand it, write down the imaginary part as v and the real part as u. Okay, and then you can obviously do it. So if we just do this,
Hello, sir.
yeah,
Are you showing the screen, sir?
yeah.
It is not visible to me.
What about others? Is it visible?
Visible,
Yes,
sir.
yes, yes, sir.
Yes, sir.
So I think what you can do is you can exit and enter again. Sometimes it does happen because it's because of the internet speed. Just exit and enter, and then I think you should be able to see it. Okay, let's check. So del u del x, del u del x is nothing but 2x, and then we can also take up del u del y. Let's do it step by step. Okay, del u del y, there is a minus sign, so there will be minus, and this will be minus of 2, right? And in a similar way, I can find out what is, you need del u del x as del v del y, and del u del y is minus del v del x, right? So maybe I can do it in this line here as del v del y. You can find out del v del y. So this is your v, so this is 2, and del y of y is 1, so this is 2x, right? And then you can take del v del x. This is del v del x. Okay, so this, you can just take this, sorry, this one, you can just take this 2, del x of x is 1, so this is 2y. Okay, and you can see directly here, from here you can conclude that del u del x is equal to del v del y, and from here you can conclude that del u del y is minus, because you see there is a minus sign there, minus of del v del x. If you look into this definition, you see that they are equal, so hence analytic. So first problems, I'm just doing it in detail, and this is the step that you have to follow. So it's not that you are going to get these simple problems when I ask you. Maybe I'll give you a bit more complicated problems and all. Okay, any kind of question, and you have to just try doing and solving it. Okay, so that's very important. So the best way is to actually practice more and more, and let's take some more sums and check whether they are analytic or not. Okay. So I'll take another example here. Here we have got the function fz is equal to e to the power minus x, and then this is cos of y plus I sine y.
No, sir.
Not equal.
No,
It
sir.
is not the stated, it is not analytic. Okay, what about del u del y and del v del x?
No, sir. These are not equal.
So both are not equal. So all of you will see this. What you can do is you can separate it out, right? E to the power minus x cos y plus e to the power minus x sin y with the I1, right? That will be v and one will be u. You can do your differentiation, and then you'll see that both of them are actually not satisfying the Cauchy-Riemann equation, and hence we can say they are not analytic. Okay. So these are simple sums you have to practice, and it's all about differentiation and integration. As far as mathematical physics is concerned, you just need to remember this condition. That's it. Apart from that, everything else is nothing but differentiation, integration, This is what we are doing for the last few days. Right? Okay, let's take one more problem. Oh, okay. Before I go to another problem, I'd just like to tell you one more thing. Sometimes they do ask you this question that show that this function is not analytic, or this function is analytic at a particular point. Maybe at, let's say, x, y. Let's say 2, 2, or maybe 0, 0 at the origin. They will say that show that the function is analytic at the origin. So there are certain functions which may not be analytic when we actually take up the equation, but when we take up a point x and y, let's say origin it will see that they are analytic. This is not the case for this particular problem, but I'm saying that that might also be a question. So even if I'm not solving these kind of problems, this should not be confusing. Okay, that means that you have to just find out del u del x. Okay, these kind of questions you have to just find out what is del u del x, and then find out the value of del u del x at that particular point. So if it is origin, maybe you have to find out what is the value at 0 0. Okay, and then you have to find out del v del y at 0 0. And if they are equal, that means they are analytic at this. But sometimes it might happen that they are not equal in general form. Okay, but then when considering a particular point, they might be equal. So they will be analytic at the origin, but they may not be analytic elsewhere. Okay, so that is another thing that you should remember. Okay, let's take one more problem. Example 3, I guess. Here I have got fz is equal to sine of z. Here you have to do a bit of expansion, advanced expansion that you should know. X plus iy. Okay, this is the function, and then you have to see whether this is analytic or not. Okay. So I will actually try to solve it, but before that you can just try, because here you have to know the expansion. That's very important. Sine of a plus b, but that is not the case. The case is what will be, let's say you have got a cos of iy, what will be the value of cos of iy? You need to remember certain things when you write down cos of iy, and if you just expand the hyperbolic function, you'll see that this is nothing but cos of hyperbolic of y. Okay, and sine of iy, check the hyperbolic function, I sine hyperbolic y. Correct. So this is the thing that you need to know in order to solve this problem. Okay, and this is something which is expected that you should be knowing. So even if I am not telling you this in class, you should be able to do it. Okay, that's very important. So that's why I'm telling you that whatever you have done in your integration and all, you need to go a bit advanced and recall everything. Apart from that, study these things also. These things are sometimes you miss out. Okay, so plus, and this will be I cos of x sine of hyperbolic y. I just replaced it. Okay, so I've got this terms now. Now this is easy, right? Now this is easy. So this is the only thing that you should know. The extra thing. Sine x cos hyperbolic y, and v is equal to cos x sine hyperbolic y. Okay, let me just do it anyway. Okay, del u del x, you have to find out. Del u del y, you have to find out. So del u del x is nothing but cos x cos hyperbolic y. Okay, and del u del y is something that sine x will remain. Cos hyperbolic y is sine of hyperbolic y. And then we can actually do del v del y. So del v del y is this. Okay, so so this will be cos x sine of hyperbolic y. Okay. Del u del y, del v del y. So del v del y, so this is cos x. This will be cos of hyperbolic y. And then del v del x is equal to del x, so this is minus okay. So you can see this del u del x is equal to del v del y, okay, and del u del y is equal to minus del v del x, right? So therefore it is analytic. So the only thing is you need to know that before you actually start. Okay, there can be one more part to this question. Okay, sometimes which is asked. Okay, you will be given this question and then you will be asked, find, let me take the same function, fz, okay, f dash z, sorry, f dash z. So in general, when you say f dash z, you can say that, okay, this is nothing but simple. This will be cos z, right? Simple. But then how do you show it using the imaginary part, So let's try doing that, okay? You can just break it off. F dash z is equal to, you can just take it to be, or I'll just write down f dash separately. U plus iv, I'll just take it in this way. We're talking about the, the z term, okay? X plus iv or u plus iv, you can take it, the w plane. Or f dash z, okay, can be written as del u del x plus I del v del y. Okay. And del u del x we have already found out. So this is our del u del x. I can take cos x, cos of hyperbolic y, and then I is there. Del v del y. Del v del y is, this. Okay. No, sorry, del v del x. Sorry, this is f dash z. Okay. So del u del x plus I del v del x. Talking about the x variable here. Okay. So del v del x is minus of sin x sin hyperbolic y. So minus sin x sin of hyperbolic y. Okay. So you see this is cos a cos b minus I sin a sin b. And if you use this property here, okay, you can actually kind of simplify this. So we can just write it down as cos x cos of iy minus sin x sin of iy. So the cos a cos b minus sin a sin b is cos of a plus b. So this is cos of x plus iy, and there's nothing but cos of z. Okay. So when we say mz, means we are talking about del of fz divided by del of x. Okay. So we'll just take z, and z is u plus iv. I will consider all the planes, okay, all the x and y term, the real and the imaginary part, and I will do it this way. So finally, I'm going to get cos z, right? So in general, we know that del z of sin z is equal to cos z, obviously. Right? So you can do it this way. This is something which you already know. But even if we use the concept of real and the imaginary part, we are also going to arrive at the same result. So in exam, if I'm asking you this question and asking you, show that it's analytic, and then you will show it, and then I'll say also find f dash z. So when I write down f dash z, that means you have to analyze it, okay, and find out the value of f dash z by separating it out in the real part and the imaginary part. And then only you can get the answer. Okay, that's quite obvious because we are doing a complex analysis here, and that is why I'd like to do this. Okay.